Hello, my name is Camilo, and this work, MUTAMA, an automated multi-level tagging approach for software libraries on Maven, is in collaboration with Roover. The focus of this work is software ecosystem, and this is defined by Lungu as software products that evolve together in the same environment. Example of software ecosystem can be found on libraries for several programming languages, such as Go, R, Python, JavaScript, etc. Uh, this work focuses on the Maven software ecosystem, which is the home for JVM-based programming languages such as Java, Scala, and so on. The number of modules in this software ecosystem have been increased over the past few years, and precisely this figure shows this kind of increasement. This is, of course, represents a challenge for developers who tries to find a suitable library for her project. This issue is addressed by indexing platforms. For example, Sonatype uh, allows the search by metadata, namely group ID, artifact ID, and version. Also, MVN repository allows this kind of metadata search, but also include categories-based search and tags-based search. Precisely this last term could be considered as course uh, features of the libraries. For example, the library Mockito core contains the tag mocking and testing, and this is precisely what is the library about. However, in this ecosystem, not all the libraries contain tags, and this is the case for new libraries arriving into the ecosystem and also for libraries that are not so popular. Hence, this work focuses on an approach that tries to propose the solution for this problem. And our approach is called MUTAMA, that stands for multi-level tagging on Maven. And we first collected a certain number of libraries for Java and Scala, and then we extracted a statistical significant sample from this number of libraries. From this sample, we were able to extract the tags. And as you can see in this figure, most of the libraries contain only one tag, and there is also a considerable number of libraries that do not contain any tag at all. However, we focus instead on those libraries that contains at least two tags because we think that the more tags a library contains, the more descriptive is the library for the developer. Then, for those tags, for those libraries only, we extracted uh, we extracted the data, but first we download the jar files, and from those jar files, we extract the public API, and specifically the name of the classes and the name of the methods, and then transform them by splitting into the camel case format. Then with these words, we vectorize those words consisting in two phases of the vectorization step, namely training and text transformation based on a word-to-vec skipgram architecture. Uh, the final vectors per word were averaged, and we got at the end a vector per library. Also for the tags, we obtain a vector, but in this case, it's a binary vector of the occurrence of that tag for a particular library. So at the end, we obtain this kind of data that will allow us to train a multi-level machine learning classifier. Specifically, we selected 5 multi-level classifiers divided by binary relevance classifiers and by ensemble method classifiers. Uh, as basic classifiers, we selected the sequential minimal optimization, which is an improvement upon support vector machine. This best classifier is the one responsible for to do the actual prediction of these multi-level classifiers. We obtain the following results divided by groups of libraries with only 2 tags, 3 tags, and more than 3 tags, and considering the metrics for the classifiers like accuracy, F1 macro, F1 micro, and Hamming laws. The best classifier was the ensemble machine learning classifier with the combination of the classifier chaining. in most of the groups and in most of the tags, this was the best model. Precisely, this best model is able to predict most of the tags for some of the libraries. Is also failing to predict some tags in some libraries, and in some other cases is not able to predict any tag at all. We think that this could be caused by several reasons. For example, that each group of this group is imbalanced, as some tags are more prevalent than others. The number of libraries for each combination of tag is small. We know that machine learning classifiers do not perform well when the data is small. API information extracted from the binaries might not be very representative because we only focus on the public API of the libraries. And finally, word embeddings of class and method names might not capture the functionality of a library. Finally, as an overview, we focus our work on the analysis of the elements of software ecosystems, specifically Maven. Uh, in this case, Maven contains several number of modules, and we focus on the tags that is missing for some of the elements of these software ecosystems. To solve this issue, we propose a multi-level classification approach called MUTAMA, and the results show that some of the tags are where the classifiers are able to predict, and we propose finally some guidelines to improve the performance in the future. Finally, we have two questions. What other sources of information could be adopted to capture in a more effective manner the functionality of a library? Something that we mentioned before. And two, in which other scenarios the approach could be applied? Thank you very much.